For thousands of years, humanity has looked toward the night sky and wondered what exists beyond the reach of our world. Ancient civilizations tracked the movement of stars, mapped constellations, and built entire cultures around the mysteries of the heavens. As science advanced, our questions became more precise, and so did the tools we created to answer them. Telescopes transformed tiny points of light into distant worlds and galaxies, revealing that the universe was far larger than anyone had imagined. Yet every breakthrough brought a surprising realization. The more we learned about the cosmos, the more complicated it became. New discoveries rarely closed the book on old questions. Instead, they opened entirely new chapters of uncertainty and exploration. What appeared simple from a distance often revealed extraordinary complexity when examined more closely. In the 21st century, one instrument has become the symbol of humanity's latest effort to understand the universe: the James Webb Space Telescope. Positioned far beyond Earth and operating in the cold darkness of space, Webb was designed to observe the cosmos in ways that were previously impossible. Its enormous gold-coated mirror and highly sensitive infrared instruments allow it to detect light that has traveled across billions of years of cosmic history. Unlike visible light, infrared light can penetrate clouds of dust and reveal objects hidden from ordinary observation. More importantly, because the universe has been expanding since its earliest moments, the light from extremely distant galaxies becomes stretched into infrared wavelengths by the time it reaches us. By capturing this ancient radiation, Webb effectively allows scientists to look back in time, observing the universe as it appeared billions of years ago. Before Webb, the Hubble Space Telescope transformed our understanding of space. Hubble's famous deep-field images showed that what appeared to be empty regions of the sky were actually crowded with countless galaxies. These observations demonstrated that the observable universe contains an astonishing number of cosmic structures spread across unimaginable distances. But even Hubble had limits. The most ancient light in the universe often lies beyond the range of visible wavelengths. To investigate those earliest epochs, astronomers needed a more powerful observatory capable of detecting the faint glow of galaxies formed shortly after the universe's birth. That is where the James Webb Space Telescope entered the story. When Webb began returning its first scientific observations, astronomers expected impressive results. What they did not expect was the scale of the surprises that would follow. Early surveys revealed vast numbers of galaxies existing at times much closer to the Big Bang than previously believed possible. Even more surprising was the appearance of many of these systems. According to conventional models, the earliest galaxies should have been relatively small, chaotic, and chemically primitive. They were expected to be in the early stages of development, still assembling their structure through repeated mergers and gradual star formation. Instead, Webb discovered numerous galaxies that appeared unexpectedly mature. Some displayed organized shapes, concentrated populations of stars, and evidence of chemical enrichment. Elements such as oxygen, carbon, and nitrogen were already present in significant quantities within certain distant galaxies. This finding raised important questions. These heavier elements are not produced during the Big Bang itself. They are forged inside stars through nuclear fusion and distributed into space when those stars die. The presence of such materials in extremely early galaxies suggests that multiple generations of stars may have formed, evolved, and expired far sooner than many models predicted. In other words, the early universe may have been far more active than scientists once believed. The implications extend beyond individual galaxies. Webb's observations are also providing fresh insight into the large-scale architecture of the cosmos. Modern astronomy describes the universe as a vast cosmic web composed of enormous filaments of matter stretching across space. Galaxies cluster along these structures, while immense voids separate them. This network is believed to have formed through the influence of gravity acting upon slight density variations left behind after the Big Bang. Over billions of years, these tiny fluctuations grew into the immense structures we observe today. However, some observations suggest that significant organization may have appeared earlier than expected. If confirmed, such findings could influence our understanding of how rapidly matter assembled during the universe's formative stages. At the heart of these investigations lies one of science's most important goals: understanding cosmic evolution. Astronomers seek to reconstruct the sequence of events that transformed a hot, dense early universe into the vast and diverse cosmos visible today. Every new Webb observation contributes another piece to this enormous puzzle. Yet many mysteries remain unresolved. Dark matter continues to be one of the greatest enigmas in modern physics. Although it cannot be observed directly, its gravitational influence appears throughout the universe. Galaxies rotate in ways that suggest far more mass exists than can be accounted for by visible matter alone. Large-scale cosmic structures also seem to depend upon the presence of this invisible substance. Despite decades of research, scientists still do not know what dark matter actually is. Equally mysterious is dark energy, the phenomenon believed to drive the accelerated expansion of the universe. Observations indicate that galaxies are moving away from one another at increasing speeds. Whatever force is responsible appears to dominate the overall energy budget of the cosmos. Together, dark matter and dark energy are thought to constitute the overwhelming majority of the universe. Ordinary matter, the atoms that make up stars, planets, oceans, and living organisms, represents only a small fraction of the cosmic total. This realization carries a remarkable implication. Everything humanity has ever directly observed belongs to a relatively tiny portion of reality. Most of the universe remains fundamentally unexplained. The James Webb Space Telescope was not built specifically to solve all these mysteries. Instead, its purpose is to gather the observations needed to test theories and guide future discoveries. In that role, it has already exceeded expectations. Every image captured by Webb represents more than a beautiful photograph. It is a message from the distant past. The light recorded by the telescope often began its journey billions of years ago, long before Earth existed. By studying that light, scientists gain access to periods of cosmic history that would otherwise remain forever hidden. Some images reveal galaxies undergoing rapid star formation. Others expose collisions between massive systems whose gravitational interactions reshape entire regions of space. Still others uncover stellar nurseries where new stars are emerging from clouds of gas and dust. Together, these observations create an evolving timeline of the universe's development. They show how simple structures gradually gave rise to greater complexity, how stars produced the elements necessary for planets, and how galaxies grew into the immense systems we observe today. Yet perhaps the most profound lesson is not about the universe itself, but about humanity's place within it. Our species evolved on a small planet orbiting an ordinary star. Despite these humble beginnings, we have developed the ability to investigate events that occurred billions of years before our world existed. We have learned to capture faint photons crossing the depths of space and transform them into knowledge about the origins of cosmic structures. This achievement represents one of the greatest intellectual accomplishments in human history. The James Webb Space Telescope continues to expand the boundaries of what is known. Each new observation refines our understanding while revealing additional questions waiting to be explored. Rather than providing final answers, Webb demonstrates that discovery is an ongoing process. The universe remains vast, dynamic, and filled with mysteries. Galaxies continue to evolve. Stars continue to be born and die. Space itself continues to expand. And with every observation, humanity moves one step closer to understanding the extraordinary cosmos it inhabits. The story is far from complete. In many ways, it has only just begun. As the James Webb Space Telescope continues its mission, the coming years may reveal discoveries that challenge existing theories, inspire new ideas, and deepen our understanding of reality itself. Somewhere within the light still traveling across the universe may lie answers to questions we have not yet learned to ask. And as long as those questions remain, humanity will continue looking outward, searching, exploring, and uncovering the secrets of the cosmos one observation at a time.